Hi everyone. Today we are going to see problems from group. The first one, if g is equal to 1 omega omega square is the set of cubic roots of unity, then prove that g is a group under multiplication. You know, group means it satisfies four axioms. What are the axiom? Closure, associative, identity, inverse. So the group they given 1 omega omega square. Okay, so for that we have to do Cayley table for doing this. This is under multiplication, right? Under multiplication, you can put star or dot, whatever it is. It's just like a Cayley table. Write all the elements from group they given 1 omega omega square. This side also, row also write the same thing, column also write the same thing. It is multiplication means you have to multiply each and every value. First take 1, multiply each and every term from the row. 1 into 1, answer 1. 1 into omega, answer omega. 1 into omega square, answer omega square. So similarly, omega into 1 omega, omega into omega, omega cube, omega square, omega into omega square, the rounded one, it is omega cube. It is cubic root of unity. That's what omega cube is equal to 1. So omega square into 1, omega square into omega, omega cube, it is 1. Next to omega square into omega square, it is omega square into omega square is equal to omega power 4. So you can write omega cube into omega. Omega cube value is 1. 1 into omega, the answer is omega. Therefore, omega power 4 is omega, right? Omega power 4 is omega. Now we are going to explain about the group. So group means it have four axioms. First one is closure. Why we are saying the Cayley table is closure? The body of the table contains all the elements from the given group is they given 1 omega omega square, right? Each and every row, all the elements exist. Therefore, it is closure. So similarly, associative, it based on it's a complex. Obviously, it is associative. Next, identity. Identity means 1. With respect to multiplication, 1 is the identity. With respect to addition, 0 is the identity. So, once you multiply 1 into 1, you will get 1. Therefore, 1 is the identity element. We want omega means what you need to multiply 1 again. So, omega into 1, omega. So, 1 is the identity element. Omega square into 1, again you are getting omega square. So, 1 is the identity element. Next, we have to prove inverse. Inverse means what? Once you multiply any two element, the identity must come, right? So, 1 into 1, yes, 1 is the one inverse of 1 is 1. So, what is the omega inverse means? You have answer must be identity element. So, identity element is here 1. So, what you need to multiply with omega? If you multiply omega square, you will get omega cube. Omega cube means 1. 1 is the identity element. So, once you multiply any term with that with the given term, the answer is 1. Therefore, omega square is the inverse of omega. So, similarly, omega is the inverse of omega square. So, each and every element, it is possible to find the inverse. Therefore, it is inverse satisfied. So once satisfying closure, associative, identity, inverse, it is a group. Obviously, the given element satisfy, it is a group. Next, you know, commutative means A comma B belongs to G means A star B equal to B star A dot B or A star B. So the same thing I can write one example for this. 1 into omega, omega into 1 is equal to omega. So this is okay, right? Therefore, commutative. Once commutative solved means it is called abelian group. Therefore, the given set is an abelian group. See, the next one is the set of fourth roots of unity. This thing you have to know. They given 4 elements. You know 1 into 1, 1. So, this thing I'll tell you. First, do the Cayley table. So, don't forget I square value is minus 1. I cube value is, you can write I square into I, that is I cube is minus 1 into I, therefore I cube value is minus I. Like that you have to multiply. So they given 4 elements, write all the 4 elements, row as well as column. Now multiply 1 into 1, it is under multiplication. 1 into 1, 1, 1 into minus 1, minus 1, 1 into I, 1 into minus I, minus I. So similarly this one, minus 1 into everything. So next I, you know, based on this you have to put. So 1 into I into minus 1, minus I into I square. So this one I into I square will come, I square means minus 1. So complete the table, and closure is obvious, associative is obvious. Next, because closure, why it is true? Because all the elements exist each and every row. Next, 1 is the identity element. So each and every row 1 exists, therefore it is identity element also satisfied. After that, you have to find out each and every element inverse. You know, once you multiply with the corresponding element, the identity element should come. So inverse of 1 is again 1. Inverse of minus 1 is minus 1. I inverse is minus I, because minus I square is minus 1, minus into minus plus 1. So similarly, you can find each and every element inverse. Therefore, it is grouped under usual multiplication using, which one you are using? Cayley table. So using Cayley table, we have proved the second problem also. It is a group. So similarly, we will go for third problem. Show that the set G is equal to 0, 1, 2, 3, etc. till 5. It's a group under modulo 6. So already we studied that coding theory. Coding theory is under modulo 2. Modulo 2 means 2 should not come below 2. So here modulo 6 should not come below 5. Am I right? So the given set is 0, 1, 2, 3, 4, 5, 4, 5. Right? Modulo 6 means 6 should not come. So once you reach the 6, subtract with 6, 6 minus 6, answers 0. Like that you have to do. Now we'll do the modulo Cayley table for this. What you need to do, write all the elements row as well as write all the elements column. Now add. So 0 plus 0, it is plus, right? 0 plus 0, 0, 0 plus 1, 1, 0 plus 2, 2, like that. So similarly here 1 plus 0 is 1. Finally here 1 plus 5 is 6. You should not write 6. So 6 minus 6 answers 0. So similarly here once you reach here 6, 6 minus 6 is 0. You will get here 7. So 7 minus 6, 1. So similarly here 0, 7, 1, 2. Like that you have to complete the entire Cayley table, and you know each and every row the 1 exists. Each and every row the 1 exists, and body of the table contains all the element, exactly each and every row all the elements exist from 0 to 5. Therefore it is obviously closure and associative. Identities exist 1 1, all the row 1 exists, and inverse means you have to find out inverse. So 0 plus 0 is 0, so inverse of 0 is 0. Now we'll find 1 inverse. Once you add 5 you will get 6. What is the identity element under addition? What is the identity element? 0. So you want 0 means you have to add plus 5, because it is modulo 6. 6 minus 6, what you are getting? 0. So the inverse of 1 is 5. So similarly find 2. 2 inverse, I have to add 4, because 4 plus 2 is 6. Again it is modulo 6. 6 minus 6 is 0. The inverse of 2 is 4. Like that each and every element you have to find the inverse. So it is possible to find the inverse, therefore it is grouped under modulo 6. So these are the pattern for, they last for problems. Okay. Thank you.